You know, there's this invisible force. It's literally all around us. It's not magic, but it powers pretty much every piece of tech you use, from the phone in your pocket to the car you might be driving. So today, we're going to pull back the curtain on magnets, the hidden engines of our modern world.
So take a look at this list. What in the world is the hidden connection here? I mean, at first glance, they're totally different, right? A car, a giant power generator, a medical scanner, a computer part, and the headphones you listen to music with. But there is a single fundamental technology that makes every single one of them possible.
And the answer? It's magnets. Yep, powerful, precisely engineered magnets. They're the sophisticated, hidden components doing all the heavy lifting in so much of our modern lives.
All right, so let's dive into our first section. We're going to pull back the curtain on this invisible engine and see just how fundamental it really is.
You know, it's so easy to dismiss magnetism as just a cool party trick, right? The kind of thing you see in a science class. But get this, it's actually one of the four fundamental forces that runs our entire universe. At its very core, it's all about electricity and motion, the movement and spin of tiny little particles inside every single atom.
Okay, so how do we go from this, like super deep quantum physics stuff, to something that can stick a drawing to your fridge or even power a train? Let's take a look at the blueprint to see how this force is actually harnessed.
It really all boils down to this one idea: magnetic domains. See, in most materials, the tiny magnetic fields from each atom are just a jumbled mess, pointing in every random direction. They all cancel each other out. Think of it like a chaotic crowd. But in magnetic materials, we can line up all these domains so they point the same way, like a perfectly disciplined army. And that collective alignment, that's what creates the powerful magnetic field we can actually use.
And we basically harness this power in two main ways. On one hand, you've got your permanent magnets. Once they're magnetized, that's it. They create their own field all the time. On the other hand, you have electromagnets. And this is where it gets really clever. You can switch them on and off just by running an electric current through them. That ability to control the force is absolutely critical for everything from those giant cranes and scrapyards to particle accelerators.
But of course, not all permanent magnets are the same. It's all about trade-offs, and engineers have to make some tough choices. Need maximum power for, say, an EV motor? You're going to go with the super strong but pricey neodymium. For a simple speaker, the weaker but much cheaper ferrite magnet does the job just fine. And if you're dealing with extreme heat, like in aerospace, you'll turn to something like samarium cobalt or Alnico because they can take it.
Okay, so we know what they are, but how are they actually made? Let's follow the journey from raw materials dug out of the ground to a finished, high-performance component.
Now, before you can even start making a magnet, you have to talk about the ingredients. The most powerful magnets need something called rare earth elements, and their supply chain is, well, it's incredibly concentrated. A whopping 85% of all refining happens in just one country, China. And this, as you can imagine, creates some pretty serious geopolitical headaches for basically everyone else.
Making one of these modern magnets, wow. It's like this incredible six-step dance of physics and chemistry. You start with the raw ore, melt down a super precise metal recipe in a vacuum, and then crush that into a fine powder. Then comes the really cool part. You press that powder into its final shape while it's inside a powerful magnetic field that lines up all the little grains. After that, you bake it so it becomes a solid block, and only at the very end do you zap it with one final massive magnetic pulse to charge it and lock everything in place.
It's a wild process, right? And it creates these parts that can last for decades. But that begs a really important question. What happens at the end of their life? And that is a huge question. To really get why it matters so much, we've got to see just how critical these finished magnets are in the first place. So let's look at this invisible engine running at full throttle.
First up, we can literally levitate trains. Maglev trains use incredibly powerful magnets to float just above the track. With almost no friction, they can hit unbelievable speeds.
Then there's medicine. We're talking massive superconducting magnets. They're the heart and soul of MRI machines. They align atoms inside your body, which lets a computer build these stunningly detailed pictures of your organs, all without a single cut.
They are also absolutely non-negotiable for the green energy transition. The super efficient motors in electric vehicles and the giant generators inside those massive wind turbines, both of them depend on powerful neodymium magnets to work their magic.
And think smaller, way smaller. The entire digital world we live in, it depends on these.
every single bit of data on a classic hard drive is stored as a tiny, tiny magnetized spot on a spinning disk.
And looking ahead to the future, magnets are at the center of one of humanity's biggest dreams, fusion energy. Incredibly powerful superconducting electromagnets are the only things we have that can contain and steer the superhot plasma inside reactors.
So yeah, all these amazing applications, they're driving a huge demand for magnets, which brings us right back to that big question from earlier. How do we make this whole thing sustainable for the future?
Well, a huge part of the answer is recycling. And get this number, it's kind of staggering. With the right technology, we could potentially recover up to 90% of those valuable rare earth elements from old magnets. That would dramatically reduce how much we need to dig out of the ground.
And scientists are attacking this from all kinds of angles. We can just salvage whole magnets, use some clever chemistry to break them back down into a reusable powder, or even dissolve them to pull out the pure elements. But the real game changer, it's thinking about this from the very beginning, designing new products so these valuable parts are actually easy to get out and recycle later on.
And believe me, the innovation does not stop there. Researchers are working on brand new magnets that don't even need rare earths. They're using 3D printing to create custom magnet shapes we've never seen before. And they're even building magnets at the nanoscale for the next generation of computers. It's amazing stuff.
So when you boil it all down, what looks like a simple little object is really this incredible blend of quantum physics, material science, and super precise engineering. They really are the quiet enablers of our modern world.
So look, as we push towards a future that's going to rely even more heavily on electric motors, renewable energy, and advanced computing, the role of magnets is only going to get bigger. The real question becomes, can we manage the super complex global supply chains and build the recycling systems we need to power that future sustainably? Definitely something to think about.